So now I finish about the fundamentals and the principle of mass spectrometry, and I will speak about the mass spectrometer because the mass spectrometer is very important in this methodology because you will see that there are different parts, and this part take into account the fundamentals of mass spectrometry. This part take a major role in the different step to perform the analysis. First, this is an injector, of course, but this is quite common in analytical chemistry. But there is different part in a mass spectrometer, and there is three different parts. The first part is the source, the ion source, and we will speak about that first. The ion source has only one role. The role is the production of ion in gas phase. The production of ion in gas phase is, remember, the two first steps for the analysis in mass spectrometry. We need to have ions in gas phase, and this is the role of the source, only this. After this, we obtain then the ions in gas phase, and we need to analyze this ion in gas phase, and this is the role of the analyzer. The analyzer allows the separation of ions in function of the M over Z. Remember that we measure the M over Z. And then after separation, we can detect this compound by ion counting, because remember in mass spectrometry we detect ions. Then we have first the production of ion in gas phase, second step the separation of ions in function of the M over Z, and the detector. The source can be under vacuum or at pressure, at atmospheric pressure, but the analyzer and the detector need to be under vacuum, and we will see why we need to have this constraint in a mass spectrometry. And finally, we have, of course, an integration system which allows to perform the signal processing and then, of course, the spectrum visualization. So now I am in the second part of this outline. This is the fundamentals and instrumentation of mass spectrometry. And I will first begin by the ion source, this presentation. So this is the role of the ion source. The role of the ion source is to volatilize and to ionize the sample, the compounds. You need to perform this before the analysis of your samples. And in mass spectrometry, you need to obtain a gaseous ion to perform the measurement of the mass of the molecule. Then, as you know, this is not possible to have only one instrumentation to perform the volatilization and the ionization of molecules, because there are many types of ion source, because there are also many types of molecules, and each of these type of source is based on different physical principles, due to the fact that there are different properties of molecules in terms of size and polarity, on everything you want. The physical principle that makes it possible to volatilize and ionize a type of compound is chosen by the operator according to the characteristic of the analyzed molecule. So it is your choice to work with the different type of ion source. You have to find a good ion source dependent of your molecules. The volatilization and ionization steps are successively or simultaneously depending on the type of source. In certain source, you have the possibility to perform first the volatilization and the ionization, and in other source, you have the two steps together, depending on the physical properties of the source. The main criteria for selection are, so you consider your sample, the volatility and the thermal stability of the compound to be analyzed. Of course, you have to see the volatility and the thermal stability of the compound because you are going to heat the compound to allow the gas state. The second properties, the second criteria is the chemical function present of their and their ability to induce ionization. You need to ionize the compound. Then you have to see the nature of your compound, the chemical function, and the properties of your compound to be able to be ionized. The size of the molecule, because sometimes this is different in terms of ionization or volatility. The size is a very important properties. And also the quantity of product available, depending on if you work in trace or if you work in a good concentration, in a high concentration. So there is different types of ionization method. And I already speak about that in my introduction and in the last session. There are the possibility to ionize neutral molecules by ejection or capture of an electron. Here you have a molecules AB, and you have an ejection or a capture of an electron. Here it is the case of an ejection of the electron, and you see that if we eject an electron, we obtain here an ions, which is an ion plus point. The point represents the free electron in these molecules. And here you have, of course, the plus charge because you eject a negative charge, a negative electron. Then you obtain this ionization. That's the first possibility. That's the first possibility. There are other possibilities, and this one are very useful, the ionization by protonation or deprotonation. The protonation consists to add a proton on the molecule, so this is ABH+, and the deprotonation consists to eject a proton of the molecule, so this is AB minus, this is the molecules AB minus H+. And then in this case, we obtain a cation. In this case, we obtain an anion. Don't forget that in that case, if I had a proton and I have to measure the molecules AB, I have to be careful that I had the mass of the proton. The mass of the proton is 1 Dalton. Then if I want to calculate the mass of my molecules, AB, I have to perform the measurement of these molecules and to make the difference of the mass of this compound, the molecules plus H plus minus a proton. And for the molecules, if I perform the deprotonation, I lose a proton, and then I have to add the mass of a proton if I want the mass of my molecules. We will see that during the practical work. Ionization, it is also possible to perform the ionization by adduct formation. It is an ion molecules reaction. In that case, for example, you have an adduct with the natrium, and then here you have the AB, Na+, which is quite similar to ABH+, but it is not a proton, it is a sodium ion. And then here you have the same issue with the AB, H+. If you want to calculate this molecule, you have to be careful that because you had in the measurement the mass of Na+. So in mass spectrometry, there are different types of ion source. And as I told you, we have to choose the good ion source for the good, depending of the nature of our compound. The ion source are classified in two categories in mass spectrometry. The category of the hard source and the category of the soft sources. Numerous ionization methods have been invented to ionize and volatilize increasingly fragile, large, and polar molecules. So today, we have a lot of possibility to perform the ionization and the volatilization of different kind of molecule, different type of molecule, as fragile, large, and polar. The hard ionization often generate molecular ions with a odd number of electrons, which fragment a lot and sometimes even completely before having time to leave the source. Their fragment can be analyzed and give structural information. So it is possible to have hard ionization, hard ion source. These ion source are considered to sources which offer a lot of energy to perform the ionization and the volatilization. And if you perform energy, if you give energy to the molecules, you have sometimes and often fragmentation. Then this source, this hard source, fragment a lot the molecules, and sometimes even completely before having time to leave the source. It means that sometimes we have only the fragment in the mass spectra. It is not possible to have the molecular peak. The other thing is the fact that generally using this source we obtain an odd number of electrons. It means that generally we capture or we eject electron, and then we perform the ionization by ejection or capture of the electron. But considering that you work with this hard ion source, it is possible with this fragment to obtain good information about the structural information, about the structure of the molecules. There are also soft ionization. This soft ionization give less energy and then generate ions with even number electron. In that case, generally this is protonation or deprotonation, which are relatively stable and have sufficient lifetime to cross the analyzer, reach the detector, and thus be measured. It means that in that soft ionization, you perform the ionization of your compound without fragmentation, and then you see only the molecular peak of your compound. So you have to choose on these two ionization modes to perform the analysis of your molecules. And the choice of this source is based on the molecules you have to analyze.